All right, sorry about that. Had to restart because I had my stream on a 1 minute delay because I was testing something last night, and 1 minute delay does not work well for class interaction. So we should be back now. Apologies for that. Anyway, um, so today we're going to pick up with software architecture. That's going to transition us into integration, and we'll go from there. So first, I just want to take a minute and review design concepts. Just as a reminder, this came up, of course, on homework 4. Namely, we talked about modularity, functional independence, abstraction, information hiding, and the basis of our design is to try to focus on these principles and create the most modularity, the most functional independence, the best use of abstraction, the best use of information hiding. Um, any questions on that? All right. So from there, remember the idea of design. The basic idea of design is to take the list of requirements, that is the needs of the customer, and design a system that has all the internal quality features that we seek. So analyzability, changeability, stability, testability, and reusability. So how do we do that? So today we're going to talk a little bit about from requirements to design. We've actually already talked about a lot of these. For example, we've talked about UML modeling. How do we go from um, identifying concepts and their relationships in order to design something? We've talked about using the right data structures when we talked about efficiency, the right data structures, the right algorithms. We've talked about refactoring a little bit. Next week, we're going to talk about design patterns. How do we go from requirements to design? We select the right design patterns. But for now, we're going to focus on choosing the correct architecture. And the idea of software architecture, it is the high level structure of the system. So that is to say the macroscopic structure. So we're not talking about the structure of any one individual class. We've already talked about how to design classes that are modular and how to have classes that are functionally independent or methods that are functionally independent. We've talked about it. We've talked about the micro level of how individual classes interact and their individual relationships. Let's take a step back and talk about a very high level structure of the system. And there are some existing architectural patterns. We're actually going to look at 6. I'm going to briefly mention these 4, but I'm not actually going to spend more time on that than needed. But let's talk about software architecture. So first is monolithic, and we have these kind of illustrations here. And monolithic is what a lot of your early programs were. A program, and again, when I talk about a program, I'm not talking about a single class. I'm talking about all of the classes combined to perform one task. A monolithic program has one or a relatively small number of classes. These classes are highly cohesive. That is to say that they all exist around performing one task. And these classes generally are kind of run by a single module. And so I should say that the classes all together, not the classes individually, the classes all together are cohesive, which is to say we would even say they're tightly coupled. This architecture, monolithic, is fine, believe it or not, if you're doing a small program. But monolithic runs into problems. It's not at all scalable. Maintainability is a massive, massive problem. From there, we also have component-based. So you can think of component-based as a bunch of individual, separate applications glued together. Now, these applications may be related, but they really are implemented separately. A good example of this would be, say, if you had like Facebook, for example. With Facebook, you have a bunch of different components: photos, wall posts, games potentially, whatever other features Facebook has added in the last 10 years. I don't really pretend to know. But the point is, all these components are glued together and they're all presented, but the components themselves can be developed reasonably separately. That is to say, they don't really affect each other. Rather, you just have to worry about some palette that all the components are loaded onto. This is good because each individual component then is relatively modular. That is to say, they have no interdependence on each other. But the disadvantage is that you have to design some base that all these components are added to, and this base necessarily is going to need to be able to be very flexible, and there may be some issues with merging new components as components are added at later times. Client server, this one is generally, you think of the internet, and you wouldn't be far off, but the idea of client server is that the client has some application that interacts with some server. Maybe it's data, maybe this server is gaming, for example. And the idea is that the client is shown some interface that they interact with. That interface sends messages to the server. The server then uses a thread to determine what to do with that user request and potentially sends information back to the client. But here then we have two very different systems. The client may have its own architecture and the server may have its own architecture. But the point is, we're dividing up some remote server with some client activity. And by the way, technically these can be on the same computer. You know, if you're using a SQL server on your computer, that is still technically a client-server architecture. Are people actually here? No one's asked any questions yet. Just want to make sure. I'm kind of paranoid, admittedly. I also want to make sure my chat didn't break again. All right, good. All right, thank you. The last one, software as a service. This is what happens when a client-server architecture loves a component-based architecture very, very much. They have a baby, and that baby is software as a service. Let me move that. Unrelated. I will answer that in a second. So this is the combination of basically component-based and client-server. The client connects to several different servers. Each server is a separate component. And then from there, so it's just a combination of client-server and component-based. So I'll answer that question real quick. The answer so far is I don't know, but I will probably defer to how Professor Sheriff wants to do things. And the simple reason for that is I'm junior faculty, and Mark Sheriff is one of the best teachers in the country. And I say that completely serious. Mark Sheriff is one of the best professors in the country in computer science, and I stand by that. And so I'm not going to try to upset the apple cart too much. From there, the next architecture you've actually already seen before, and you may have implemented Homework 5 with an architecture like this. The idea is model, view, controller. And we actually have, this word controller should stick out to you. The idea is that the user is presented some view. The user then chooses to interact with that view through a controller. So you remember when you create that fxml file and you made a controller class? That is the controller class. That's where you put things like your action listeners, etc. And that interacts with some model of data. So for example, you probably had some underlying class to model the Super Tic-Tac-Toe board game. That Super Tic-Tac-Toe board game, the actual basis of that, is within the model. The controller simply interacts with that. The model sends information back to the controller like, hey, someone's won the game is over. The controller then updates the view. That is to say, it changes something about the presentation to inform the user that the change has occurred. So if you'll notice, there's kind of a tight circle here. The user interacts with the controller. That is what they see as the interface. So they hit a button or they trigger some action listener or whatever. That updates the view. That is, updates what the user sees. The user then sees that. That's interacting with them. So we have this tight circle. The controller also is responsible for interacting with the underlying data. So that is the model. The view doesn't directly access that. And the model is aware that there's a controller. It knows it's sending its function somewhere, but the model has no direct access to the view. That is, no direct access to UI elements. And that's by design. And that's going to relate to a bit of what we're talking about today. So now, what kind of architecture can anyone think of another architecture we've used? Maybe think back to homework 3. Does anyone remember what we called that? It wasn't MVC. Can you TA next semester? Yeah, so apply to be a 3240 TA. This class won't exist. 2501 SDE won't exist. 3-tier, right, exactly. 3-tier architecture. And so today we're going to take a look at that 3-tier architecture. We're going to talk a little bit about some of the benefits and what to look out for. So the first thing I want to do is I want to draw what I mean by a 3-tier architecture. So let's take a minute. Let's pop on over to the... Oh, hang on. Forgot to set my camera up. Let's see. A little bit too high. There we go. Okay. Where did my markers go? There was one. There they are. Okay. So, with our 3-tier architecture, and by the way, technically you can call this N-tier architecture, but it just so happens that the most common architecture, so again, N-tier, the most common is a 3-tier architecture. Now, technically we can have more tiers, but generally we focus on 3-tier. And at the top, we have the presentation layer. And the presentation layer uses, and I'm actually using the UML dependency arrow here, uses a controller layer. And the controller layer uses a data layer. And each layer serves as a different role. The presentation, this is where you're going to have your UI. This is where you're going to have your user interaction. So whether that interaction is through a GUI or through a command line interface, this is the only thing the user interacts with, is the presentation layer. The controller layer presents a menu of options. And that menu of options is basically a set of queries that the presentation layer can perform. And I say queries with the air quotes here. And I don't need to actually show that slide at the moment. I say queries with the quotes there because I don't necessarily explicitly mean MySQL queries. In fact, here, I very much don't mean MySQL queries. And then at our data layer, this is in charge of creating, maintaining, and updating data. So presentation layers at the top, this is what the user interacts with. The user doesn't see anything below this. The presentation layer queries a controller. That controller presents a menu of options to the UI. The controller then doesn't actually execute those options. Rather, it communicates with a data layer to have the data layer execute those options. This is a 3-tier architecture. And again, we could expand this to as many tiers as we want, but this is the most common. And you generally won't see less than 3 because then you're combining 2 kind of different layers. So why do we do this? Well, let's take a minute and let's consider a presentation layer. Let's say we had some kind of presentation layer, and by the way, this code is uploaded, that looked a bit like this. The idea is this presentation layer might have some function present. It's going to print a prompt, and let's say this would be something similar to what we did on homework 1 with the states and tweets. And let's say we enter our choice, we get the user input, we get it as an int, and if that choice is equal to 4, then we do something like string get state being a function that prompts the user for a state. We then query the controller, hey, give me a list of tweets from that state, and then maybe we print every tweet, or we do something with this tweet, maybe get some summary data, whatever. This would be what my presentation layer would look like. And notice this is where we have things like system.out.println, we have a scanner that's getting user input, etc. The presentation layer is also going to have a controller. So in this case, I create the controller as a new controller tier object. But the point is the controller is an object. It's not necessarily static functions. It is an object that the presentation layer is interacting with. And it would do something like this. The presentation layer, again, is responsible for displaying the interface to the user. It is responsible for getting inputs from the user, and is responsible for interpreting those inputs into what action to perform. So this is the presentation layer all kind of wrapped up. And by the way, this code is not anything complete. You have a complete 3-tier architecture if you want to re-download the homework 3, but I want to just get to the bare bones here of what each layer is responsible for. From there, the controller layer is simply going to present a list of options. For example, a function like public get tweets for states, and each function is a different option potentially for the user interface, or at least a different query the user interface may need to perform. Now the controller also has, the controller also has a data tier. That is to say the data layer, that is to say the bottom. So technically, if we're really drawing this in a UML kind of way, what we would actually do, and by the way, you can do this with just dependencies and have static functions, etc. But often, the way I implement this is actually this. It's a has-a relationship. This is and actually you don't draw an arrow there. You just do just a fixed line like that. Technically, this would be a has-a relationship. The way I'm implementing it here. Again, could be use, could be static classes, whatever. Point being, this is how it's implemented in the code. Anyway, so now each option the user may need is presented as a single function, a single public function with a public interface. Now the key for this function is it should take in some input and effectively pass that input to the data layer, or at least extract the data and only perform very simple operations. For example, this might be something like get all tweets. This would be the data manager has a function to get all the tweets. The data layer also has a function that determines the state from a location. And all we do here is simple filtering. So this is about as complex of data operation you should do in the controller layer. Just simple, hey, I have a list. Let's do some basic filtering here. You really shouldn't do calculations necessarily in this layer. From there, of course, we have our data layer. And our data layer is where we're going to have functions like get all tweets, get all states, get a state from a given location, whatever. But this data layer is only in charge of, first, this would be getting the data. It might be in charge of creating the data, that is, reading in the files or loading up the database. And it will be in charge of manipulating the data. If some piece of data needs to change, such as something like, let's say we finally get our act together as a country, and we have a function, remove state, public void remove state S. And this function would remove that state from this list. And if we got our act together as a country and finally got rid of Ohio, this would be a very useful function to have. But the point is, this is in charge of creating, maintaining, that is, storing, and then from there, manipulating. Now, if you want to know why I hate Ohio so much, it's because I'm from West Virginia. My family still lives in West Virginia. And I had to I lived in Indiana for 4 years doing my PhD, and so I had to drive across Ohio. And Ohio apparently teaches people it's totally fine to go 15 miles an hour below the speed limit in the left lane, and then when someone passes you, to speed up, and then when that's done, they slow back down. So my point is, I don't like Ohio very much. Anyway. So with that, presentation tier is going to do presentation tier presented to the user, what options are presented to them, how the user interacts, how the user interactions get into the system. The controller maps the user gestures, that is the user requests, to data layer methods, and then the data layer actually is where the data is stored, calculated, etc. Ohio does have a stay-at-home order. They're actually one of the earlier ones. Credit to them. But I think that was more just out of they didn't want people driving anymore because no one in that state knows how to drive. Anyway, yeah, there are 7 without a stay-at-home order. Anyway, with that, let's take a step back over to the whiteboard. And I want to point some things out here. We've talked before about the principles of abstraction. And the idea of abstraction is... Where did my purple marker go? That's not the idea of abstraction. That's just a general question I'm asking because my purple marker is gone. Oh, there it is. All right. So the idea here is, remember, if presentation has a controller, this is a dependency. This is just a specific kind of dependency. So presentation depends on controller. Controller depends on data layer. Let's say, for whatever reason, we had to update our data layer. And we had to update it in a way that did change the interface. Let's say I had to update data tier in such a way that now get all tweets takes in something like string source. And this takes in a source, whether you want to use a file or a database or whatever. Something like that. Well, because I have updated this class, the getAllTweets function, necessarily this is going to affect the controller tier because this line of code no longer compiles. So necessarily, I now have to make changes to the controller tier. Now, depending on whether or not I'm adding a feature, it may be possible to limit this change to the controller tier. For example, let's say I just define string, oops. Hey, here's the storm started an update. All right, can't wait to play. Sorry. I actually do really like that game, for the note. String source equals database. Maybe I have just a statically defined constant, something like that. At that point, if I can do something like this, I could update this to take in source And now notice the red line gods are appeased and they have gone away. This code now compiles. And if I can do this, if I can make this change, then notice presentation tier is completely unaffected by this change. That is to say that if the interface changes of the data layer, if this interface changes. So again, we're talking about the public interface changes. Necessarily, that will impact controller, that will cascade up. I will have to make changes here. But it's possible that I can limit the changes to the controller layer. It's also possible that I can't. For example, what if what data source I'm using is selected by the user? So maybe now the user needs to change something like maybe if choice equals 5, something like string source equals get new source. This would be a function. This would be a function that prompts the user to define a new data source. Maybe that's a database. Oh, I am not screen sharing. Sorry. So again, the idea here is if I cannot contain that change, if for whatever reason I can't do this, maybe the user does need to have a say in the source, I can update my presentation layer and maybe add something like a choice. Option 5 would be change the data source. This would get the user source, so maybe something like return database. I don't know what it would return. This is all very hypothetical. But the point is, this would be replaced. So right now, this is a stub. I would replace this with something that prompt the user with a scanner. In dot whatever. I would then say something like controller dot update source. This would then go to, I would need to add a method like this to the controller tier. Create method update source. This would take in string news source and source equals news source, something like that. So now you can see the point being, because I could not limit the changes to the controller layer, I do have a potential possibility where some change, especially if it involves implementing a brand new feature, may require a bottom-up integration, or maybe even a top-down integration, but we'll talk more about that on Thursday. The point being, because I made a change to my data layer's interface, it's possible I can't limit that change to the controller, and I'll necessarily also need to update the presentation, especially if it's a brand new feature from scratch. But more often than not, I can either limit that change to the controller, or even better, I can change the data layer such that I don't change the interface. I don't change it at all. Hypothetically, let's take a step back. Let's go to the data tier, and let's say that this function, and I'm going to leave in the stub for now, return null. Let's say that initially, what this function does is it reads in data through a JSON in the data tier. What if we change this? What if we delete this functionality and now we read in data from a SQL database? So I would change the implementation of this function, but I would maintain the same interface. The interface wouldn't change. What other layers would be affected? Because I've updated this code, but I've maintained the interface, what would happen to my controller layer? Anyone? What would be the result? What would I need to do for my controller layer? Nothing. Exactly. Apparently, I'm dropping frames. My internet's acting up. I apologize. But so if I do lag out for a bit and you miss something, please don't be afraid to ask. Assuming that the controller layer doesn't need any new interface, and the bacon's asking a great question, and I'll come to that in a second. Assuming this interface doesn't change, the controller can still call this function and be completely unaffected by it. This allows the underlying data source to change without me needing to update the controller. Now, what the bacon is pointing out is great, again, assuming you don't need the controller to tell you what database to use or something like that. If the controller needs to tell the database what data to use, that would require changing the interface. And at that point, if the interface changes, so going back to the whiteboard, if the interface of the data layer changes, necessarily the controller will need to change. And if the interface of the controller changes, necessarily the presentation will need to change. These changes cascade up. But if the interface doesn't change, but the implementation does, if the interface does not change, but the implementation does change, I don't need to propagate that change at all if I maintain the interface. There's another advantage. Let's say our presentation needs to change. Let's say that users are telling us that we need to change how our presentation looks because it's not very user-friendly. And so we need to restructure the UI and change some of the button action listeners, etc. Let's assume that we change the presentation, the user interface dramatically. What other classes do I need to change? If I make changes to the presentations interface, does that propagate to controller? And I'm going to erase these errors for a second. If I change the presentation layer, will that change necessitate me changing the controller layer? Again, I'm not adding new features. I'm just changing the interface of the presentation. The answer is no. If I change the UI, it is immortalized on Twitch, sorry. No, so if I only change the interface, again, I'm not adding new features, because remember, I can't add new features only to one layer. If I'm adding a new feature, that requires adding the feature at the data layer to have the data to support that new feature, at the controller layer to present that new feature to the presentation layer, and at the presentation layer to present that new feature to the user. Yeah, but the thing you're forgetting is I'm highlighting these VODs, and they don't get deleted. Actually, I haven't been highlighting the VODs lately. Anyway, so the point being, changes cascade up, changes to interface cascade up. They do not cascade down. And so if I made a change, say, to the controller layer's interface, let's say this interface changes. If the controller layer's interface changes, necessarily that change will propagate. I will have to update the presentation layer. But I may not have to change the data layer at all. Again, unless I'm adding a brand new feature. But if you're talking about adding a new feature, you're talking about full stack, from data to presentation. That is to say, if you've ever heard these terms, this is the front end, and this is the back end. And if you ever hear the phrase full stack developer, a full stack developer is someone who potentially works in the entire space. But generally, we think of the presentation as the front end, the data layer as the back end. And so, if I make a change to the controller, yes, that will propagate up, but it will not propagate downward. So this limits my propagation. Can anyone think of another advantage? Can anyone think of something that we could easily do? Right now, this interface is command line. Can anyone think of something we could do to this system rather easily now, given what we've taught in this class? Maybe hypothetically 3 weeks ago. I could make a Java FX interface at the presentation layer. And in fact, I could do this in such a way that I don't actually I don't change the layer. I could leave this layer completely alone. And what I could do is I could say, okay, let's make a second presentation layer, and this is my Java FX. And this is a GUI app. And that GUI app is also going to have a controller. I would do something like, going back to screen share, I could do something like create a new Java class, Java FX UI. That Java FX UI is still going to have, similar to the presentation layer, it's still going to have some controller layer. So controller tier controller. It's going to have a constructor, same as before, public Java FX UI. Controller equals new controller tier, something like that. And then from there, if I were writing, say, an action listener, where the user enters into some text box a name of a state and then hits go, that function may look like public void get tweets from state action event E. This would then just do something like text field dot get text string state name equals that. Then from there, I'd use this to generate the state. Again, technically in this presentation layer, I don't say how the state comes from. I just store it as a string. And then from there, I could get the tweets from the state exactly like I do in this presentation layer. I could do exactly this line of code, copied and then pasted. And yes, I know this is not compiling, and it's because I don't actually have a Java FX UI that I'm reaching out to. I'm not going to actually do all of this today. I just want to show that I can make this change. And this would be state name. And then from there, instead of printing to the command line, it might be that I write this all to some string. Oops, not what I meant to do there. Instead of printing to the command line, I might write this all to some string. So I do something like string builder SB equals new string builder. And then instead of system.out, I do sb.append t append new line. If you're not familiar with a string builder, it has the same amortized benefit of an array list. Whereas string concatenation is typically linear time, and if you do a lot of string concatenation and string concatenations, that makes it quadratic. This is still amortized linear time. And then something like display area. This would be, say, a large text display area. Display area dot set text sb.toString. And this could be how I display in the UI. And notice, this is not much different than how the presentation tier is implemented. And that's actually the point. Java does use it under the hood when you concatenate, but the problem is that Java only uses it under the hood, not in every situation. Technically, it only has some optimization. There are blind spots to that optimization. But that's actually, the fact that Java uses a string builder under the hood should tell you that that's why the string builder is beneficial. There are some blind spots to that optimization. I should note that optimization is actually relatively new. I think before Java 8, it didn't do that. And I actually had problems one time with efficiency with code in Java 8 because I didn't use a string builder. Also, I should note that SIS does something similar with string concatenation that makes it quadratic, which is one of the many issues with that website. Anyway, the point is I now can have two independent presentation layers. Can anyone think of an external software quality element that this is going to help? An external software quality metric that having multiple presentation layers is going to help. I won't say that out loud, but the fact that I'm, not usability is related to this, but there's actually a separate one. There's functionality, there's usability, there's efficiency. There it is. Kelly got it. Portability. Because now what this enables us to do, and keep in mind, this entire architecture doesn't have to be implemented in one language. For instance, this could all be implemented maybe on a web service server. And this could all be implemented in, say, something like JavaScript. Or maybe even the controller's implemented in JavaScript, and this is in a server just running Unix or something like that. This all doesn't have to be one language. And so, if you do, say, a web service as JavaScript as your controller layer, this presentation could maybe be implemented in Android, which uses Java, and this presentation could be implemented in iOS, which uses, I believe it's called Swift now. It used to be Objective-C, but I think it's called Swift now. And this allows you to develop an app with only one controller and data layer, but with different presentation layers. And yes, you do have to develop these independently. That's a little bit of a downer. You do have to develop the interfaces independently, but it's not the full stack independent development, which is how things often were. Video games during the Sega Genesis and Super Nintendo era, if you wanted to release a game both for Sega Genesis and for Super Nintendo, you actually had two completely independent full-stack developments with the same features, but there was no easy way to port between the two because they were very, very different processor architectures. Is there a primary motivation for client-server? And so the primary motivation of client-server and software as a service, and let me pull those slides back up, is the idea is you can think of this like going to a restaurant. This is the client placing orders. This is the server performing the tasks. And the advantage is it lets you separate the concerns, again, modularity of presenting options to the user and taking orders, separating that from a location that actually performs the task requested. Further, client-server, I mean, this is an architecture out of necessity in a lot of cases. If you're doing internet-type work, you can't move a program over a network cable. Like you can't move a running program over a network cable. You can move signals over a network cable. Those signals can be interpreted as data, and so it's very easy to move data from the client to the server and back with the internet. It's much harder to move a full stack of here's the memory of the program, here's the stack, here's the heap, etc. So you basically have two different systems connected by some line of communication that sends data, and that is what the internet's generally good for. By the way, fun fact, because I've seen this meme pop up where people are like, "Oh, gamers need to stop playing games because they're using up the network." No, we're not. Netflix at high definition will be like 3 gigabytes an hour. Heroes of the Storm is like 15 megabytes an hour. Anyway, just thought I'd put that out there. But the point is, this is an architecture that was created largely out of necessity for remote systems. And then software as a service, it's the same motivation as client server, except instead of one server, you have several different servers that each serve as different components of the system. But that these servers all behave independently. Or at least almost entirely independently. Any questions, otherwise we're going to wrap up very early. Any questions about the presentation layer? Or, sorry, about any of these three layers. And by the way, you can have multiple data layers. It might make sense for me to have, say, one data layer that's for maintaining tweets, and then an entirely separate data layer for maintaining states. I think I actually have an example of this in Homework 3. In Homework 3, I separated out these two concerns. I even had a separate data layer for state finder. That is to say, given a coordinate, find the nearest state. So you can have multiple data layers. You can also have multiple controller layers. For example, if you have multiple features that actually really are not modular at all, that should be separate concerns, something like separate components, those can be implemented as separate controllers as well. So the presentation can have multiple controllers can have multiple data layers, but they all at least have one. And I realize that whiteboard looks kind of like a crazy person right now, so I apologize. Any other questions? Would those be considered different layers? So they would be considered the same layers, but different modules. Because remember, a layer is not something that exists in a programming language. It's an abstraction. And so the idea is I'm defining a layer. I'm defining a layer based on what purpose it serves. And generally, it makes sense to break that into all the things above this line are presentation focused. They're focused on presenting information to the user. All the things below this line are related to creating, manipulating, counting data. And all things in the middle are for connecting the presentation to the data. So how do you avoid coupling? So all I would say is in order to avoid coupling, you need to make sure that the relationships are one way. You should never have the controller even aware the presentation exists. Notice, so you're asking a great question. The question is, how do you avoid coupling? The answer is no mutual dependence. So coupling is generally caused by when the presentation depends on the controller and the controller depends on the presentation. Don't make the controller even aware that the presentation layer exists. So this is my controller layer. Do you see anything referencing a presentation layer here? What you would do is if you need to send, say, more than one piece of information to the user, you would have one function that says update the data storage in some variables that exist inside the controller, and then have the presentation layer access that. The key is the controller should not even be aware the presentation exists. And if at some point you feel that the controller needs to get some information from the presentation, then the presentation layer should have already sent that information. So you need to go back and look at your call stream and maybe have another function call in the presentation layer before the one you're on that sends that information. an example, and it's going to take me a minute because I haven't downloaded it on this computer before. So give me just 1 second to pull up homework 3. Because I actually do some of this on homework 3. You're asking a very valid question. How do you avoid coupling? The answer is it's not easy. It requires vigilance. But give me a second as I am pulling up the homework 3 starter code. Let me copy these folders, and I'm just going to drop them in here, and it's going to look really ugly, but whatever. So one of the problems that I ran into while designing the homework 3 system, and this was a problem I ran into, is in the controller layer, I had to consider the possibility. What if... where is it? What if this state doesn't exist? How would I inform the presentation layer that this state doesn't exist? And I thought maybe I need some way for the controller to communicate to the presentation layer, hey, this state doesn't exist or whatever. How do I solve that problem? The way I solve that problem is by adding more interfaces to the controller. Namely, I added a function, public boolean is a state name. And this is how I check from the presentation layer whether or not a state exists. I don't leave it up to chance that this function's called. In fact, with this function, I assume the state name is real. And then in the presentation layer, what I do is I get the user, I get the state entry, same as I diagrammed before, but then from there, I actually immediately check. So there's no coupling here. Could I also have the controller throw an exception? Sure, I could. The problem with throwing an exception, as we've talked about before, is technically you want to make sure that exception's communicative. So that would work just as well. But the point is, if you look at my homework 3 code, there is no point. So I'm in the controller right now. There's no point that the presentation layer is referenced. The controller is not even aware the presentation layer exists. I don't have a presentation layer object. I have no access to the presentation layer. Second, if you look at all of my data layers, I technically have 3. I have state finder, I have state reader, and I have tweet reader. These are not aware that the controller layer exists. They're not. This class is not aware of where it's being called from. There's no controller object. And that's intended because these dependencies are one-way streets. Going back to just this 3 I started with. The controller layer should never, never, never be aware that the presentation layer exists. And the data layer should never, never, never be aware the controller layer exists. Because if you don't have a mutual dependency, then it's much easier to avoid coupling. Because coupling starts from mutual dependencies. So in fact, not only does not, going back to my code, not only does not the controller layer interact with the presentation layer, it can't. Because the controller layer is never aware what presentation layer is using it. So I don't have to worry about, well, what if it's a UI or what if it's a GUI? Because it doesn't matter. I can't know what type of interface it is anyway, because that information isn't available. All I need to do as the designer of the controller layer is focus on what queries I'm making available and how to amalgamate that data. So that's how I avoid coupling, is by making sure that there is no mutual dependence. Higher tier architectures. So some things you'll often see is you'll see a separation of the data layer, which presents tools to the. So you'll see something like the data presentation layer, and then you'll see below that something like the database level. And this would be where you'd be, your SQL databases, which are often represented as a cylinder. Look at my amazing artwork. I know that's horrible, but this is often where like your SQL database is going to be stored. And this is actually not in the program, but rather the data layer interacts with that, and we could actually think of that as a separate layer. So again, the idea of a layer, this is not something that like, this is not something that was etched on a stone tablet, but rather something that we've created. And it is a little bit murky because it's an abstraction. It's designed to be an abstraction of a concept, not a translation of one. Any other questions? So again, I mean, you can add as many layers of abstraction as you want. 3 is kind of the bare minimum, and that's just because you need the presentation, and then you abstract out the features, the list of features, and then you abstract out the data that implements those features. And anything I implement at scale anymore, I use 3-tier. Because once you kind of get some practice with it, you'll find it's useful. Unfortunately, there really isn't time in this class to do a project with a full presentation layer, which was originally what homework 7 was going to be. But given that we lost effectively, a class period paired with delaying the exam, it's made it where I'm not going to have a full development 3-tier architecture process. All right. If there are no other questions, I'll go ahead and wrap up here. I'm going to put the notes from earlier back up, the announcements in case anyone missed them. The exam 2 scores are up. You should be able to see your feedback per question on Colab, as well as your raw score in the quiz. But on the grade book, you'll see your curved score. The quiz was curved, the exam was curved. Quiz 7 will be, quiz 8, which is the next quiz to come out, will be the last quiz. And that will relate to this, integration, and then design patterns that we'll talk about next week. Homework 6 is due this Friday. Homework 7 will release Tuesday, and it's just because I don't want to introduce the homework without discussing design patterns. So. And again, I have office hours today. They're completely unaffected today. Tomorrow, my office hours are moved to Thursday 2 to 4, and I apologize, but that's just a necessary change that I have to make. All right. With that, I will see everyone on Thursday when we'll talk about integration. Top down, bottom up, and big bang. Talk about that next time. Take care.